This is Communication Systems 1, a very fun class, along with any class that I teach, unless it's something that I have to do as an admin job, I think is fun. If it's teaching, it's fun. If it's not teaching, like the faculty search committee I'm chairman of, I'm not excited about that. That's 100 resumes that the committee has to go through, but it is going to bring us a power systems faculty, hopefully by next fall. So we will have somebody in power systems. I'm just not a power systems person. I'm a user of power, though, like almost all of us in here. I mean, I'd say all of us, right? Does anybody not use power? Okay. Makes me think of something else, but I won't sidetrack in it because they were campaigning out there that I ran into somebody talking about global warming. And the colors don't look right either. It looks like we're missing one of the colors from the video, right?
Green.
How can that be, though? Dirty connector? I don't think so. I guess I could call the IT people on that one, too. I've had these problems like this before. It's kind of a bad deal because I can't really change any of that unless this video switcher thing. Do you mind if I call them right now? Because I like to get these things resolved. All they do is frustrate me later. So I'm in B211. So I'm supposed to call 4963. Andrew, this is Professor Mark Wickard in Osborne B211. I'm having problems with the projector. It's got a video issue where I've only got 2 of the 3 colors coming through from my laptop, and I think my hardware is good. I'm suspicious of something going on here. Yes, I'm an electrical engineer. I do things like that all the time. I'm going to be lecturing, and I'm having problems with the audio on my system too, but I want to make progress, but I just wanted to report this because I would like to have all 3 colors rather than this kind of strange color scheme I have right now. If you come in the classroom while I'm here, that's fine too. I don't care. Okay. Okay. You're on video now, or you're on screencasting because I'm capturing our conversation just by happen chance. But at any rate, I'll be seeing you then. Bye. Put in nice new Cisco phones, though. I don't remember those before. Okay, so Com Systems 1 is followed by Com Systems 2. And then something that is parallel with this right now, concurrent, is the lab. And I wanted to do some talking about the lab because the lab has got only a fraction of a unit. I think there's 4 people in the lab, and the lab has space for 12 people. And that's why I brought some test equipment down here and things of that sort. So I'm going to get into explaining that as I move into things. But right now I'm starting on the website for the class because this is where you're going to get information about what's going on in class. Did I forget something? Did I forget to announce that we are going to have a quiz over the homework and so on and so forth. So just to get familiar with how the web page is set up, the left column has the news for the day on it if I have something new. So for today, I left my first sentence up there just to say welcome, and that's been up there for quite a few days, but then I did update problem set number 1 with some changes to problems that I had from last year, so that is now available, and I've handed that out to you, but if you need to get it fresh, it's going to be right here, and this list is going to just keep growing, and it will have a hints page added into this part of that bullet, and then it will eventually have a solutions page which will be locked with a password on the PDF. So that will just unfold as time happens. And quizzes will start appearing here too. The quiz solutions will. The quizzes will be handed out in class generally I've been doing them the start of class. So there will be like, we get into class, it's time for class to start, I'll hand out the quiz, and then I'll start a timer, and it will be, I think it's 15 minutes is what I would give for a quiz. The lecture videos are all up here. This was a page I was in the midst of fixing when something happened, but that spring 17 is kind of old information, but everything else is correct from last year. And it looks like I missed the first lecture video last fall, so Chris, that's not a good deal because I only have spring of 18 up here. I don't have spring of 19. It must have been a technical difficulty when I got started. But this will unfold as well, so I'll make everything red on here, and then as I'm adding in new ones, they will become green, and then if I have an old one, then I will sometimes, I guess here I'm not doing it. In some classes I keep 2 sets of videos, but for this class it looks like I only keep 1 set. So we're doing 1A right now, and if I get something, I will put it up, and then I'll just replace things as they happen. And it's all subject to, you know, things like snow days, things of that sort, things that happen like that. So that's up there. Likewise, exams will eventually appear with solutions ahead of time. And then there's Python projects. These are the projects from last spring. What I will do exactly here, I tend to use mostly the same projects, but I make adjustments to them. So what I don't want you to do is pull a project down and start working it saying, I'm going to do this, and here it is. If it doesn't have a 2020 date on it, it's not the right thing to do because I might change something. So just don't get so excited. It's missing the red, I believe. And I did wiggle it a lot. And this is a pretty new dongle off of this Dell system. I've not really had a problem with it in the past. If you want to wiggle it yourself,
so
why don't I stop my video for a second so I don't have to.
More than likely.
Of the opportunities that you get. We're back on video now. We were working on the projector, but you didn't lose anything except a demo with a spectrum analyzer in the lab here in the classroom. But my feeling about electrical engineering, we sit kind of in a really nice spot where we can touch the hardware, interface to the physical world, and then write software and firmware to do things with it. After all, this is my negative part about just being pure software, a computer scientist. You can't do anything with software unless you have something to run the software on. And what are you running the software on? It's electronics, right, of some sort, devices and programmable things. So software alone wouldn't exist without hardware to run it on. I don't know, have you ever thought about that? Or maybe that's why you're in EE, because you realized that and you said, I want to be more than just write software. Although software is a lot of what engineers do these days. Modeling things, of course, too. Since we were talking about SDRs, I'll just pull another one out and then I'm going to plug this in. This is one that I've started, it's been around for a couple of years, but I had it in the hands of a graduate student. This is called Pluto from Analog Devices. These sell for about $150. This one that I'll demo sells for $20, so it's a lot less expensive. This was developed for digital video broadcasting in Europe, so it's a commodity item that was repurposed by creative people for programming and writing your own algorithms for. This one was developed by Analog Devices to help sell their chipsets for software-defined radio, but they developed it for the educational market. This one has 2 antennas because it transmits and receives, and at some point, I don't have the drivers and things on this tablet, but I'll have it up here. So this is something that's got me excited. And Andrew and others on the team of the Psych at DSP.com, we're rearranging some things, but I hope to have this more stable at some point. What's cool about this is you can transmit and then you can receive right next door. So when I'm playing with this right now, I can put a cable between here, but I can just have those two antennas in close proximity, one transmit to the other, and I'm playing with it in the Jupyter Notebook, and it's cool. I mean, I like it. This tunes from 70 megahertz up to about, I think it's 3 gigahertz, 3.5 gigahertz or something like that. Since I've been around a long time, these things just keep pushing, and I'm just waiting what it's going to become. The price, you know, this is a little bit pricey, but still not too bad. It's just things become more available for less money. So since I'm off on this software-defined radio tangent, I'm going to plug this in to my hub, and hopefully I'll be able to get it to come up through this interface. Maybe it's going to be telling me there's something wrong with this Dell dongle, and that's the reason why the microphone's not working, because it didn't go ding-dong, so it makes me think there could be something else happening. This will tell me pretty quickly. Yep, no device selected. So I bet this dongle is now not talking to this USB 3 hub. So what I'm going to do, that's probably it. So I probably need to reboot. Some driver changed when the Windows patch came through last week. So I've got my USB to USB-C. I'm going to put it in where the power cord is going into my tablet on the other side. And this is what I was doing just before class. Yep. So maybe I should run on batteries and plug my microphone in over there, and maybe it'll start working again. Yeah, there it is. So this is classical music. I'm not going to tune around, and this is a good little demo because it also lets you see something about FM broadcasting that maybe you didn't know, and that is, this is KCME, but then those rectangular spectral blocks that are also part of its broadcast. What's in the center is the legacy analog FM modulation, which we'll be talking about later in the class in chapter 4. And you can see it's kind of fluctuating as the music is doing its thing. If there was a speaker on it, it would definitely look a lot different. But the rectangular pieces are a spectral overlay that was added more recently. Does anybody know what that spectral overlay is? It's for HD radio, yes. And that's something that is proprietary to the company that developed it and sells it. So a lot of the stations in Colorado Springs have HD. KCME, if you're listening, I only have it on my car. Standard. So when I tune to KCME, it will put up 2 extra buttons saying you want to listen to HD, and there's 2 different broadcasts on the HD portion. There's the same thing that the classical, and then the jazz station that they have is also on there. If you listen to the Christian station, KTLF, it has 3 extra broadcasts that are on there, one being the same as the analog and then 2 other programs. And I guess the other stations do something similar. I don't listen to those channels, but I'm guessing they do that. Does anybody do that? Listen to HD? It's free. It doesn't cost you anything. The hardware costs you, and it's proprietary. I've tried to understand how it works. I can't. I mean, there's a book available on Amazon, and you have to buy the book, but I don't think it tells you a whole lot because it is an intellectual property thing. It's kind of a secret what they're doing with that. But it tells you about something about communications technology and communications theories, that legacy standards stay supported, and then they augmented it with this overlay. I think it takes up a little bit more spectrum to have that out there, but it is something that a lot of things do in our world. I mean, in terms of technologies, we keep existing standards and we augment them. So in your life, you won't work on systems or components or whatever that are brand new. I mean, it's one of the things I think when you're a student, you think, I'm going to design something from scratch and it's going to be the first of its kind. Sorry, not very many people do that because, we're so entrenched in just epsilon, incrementing our technology base. You can't have 5G, for example, immediately. It's very expensive to upgrade all the base stations. It's very expensive after I'm buying a handset too. But, I remember when, because I have AT&T for my cell phone, they wanted to sell me a new phone, and they said you're going to have 4G. And I said, okay, so are there any 4G cell sites in Colorado Springs? In South Denver, there's one. I said, well, why would I want this new phone if I can't use it? I mean, some of you have been there before. It's like the technology exists on one side, but not on the other side. So that's another thing that is kind of intriguing. So what was your question?
It just seems, I know it's like the minus 3 dB point, but that seems like it's very high gain white noise.
I mean the rectangular blob here?
No, just everything around.
Everything? That's just the noise floor that's come up from the receiver because of the sensitivity. You're bringing up a good point, though. There is noise. There's always noise in a receiver front end because the signal is weak. I'd be willing to bet that, well, maybe not. It goes through the walls. FM is short enough wavelength that it goes through the studs. They're far enough apart. But that is a pretty good, if that X is a pretty good screen. So I've seen situations where metal blinds, if you open them up, you might actually change the signal strength. That's a propagation thing, which I'm already telling you now that communication spans a lot of things because we touch the RF and microwave and fields and wave side of things, and then we go off into the software, firmware, all that other kind of stuff. So I'm interested in, I kind of minored in electromagnetics when I was in school and then did those types of things.
And did you say the notch? And now that you mention it, what are those notches?
Well, these aren't notches. These are just the overlay spectra that contain the digital HD broadcast. So it's encoded digital, whereas this is just analog modulation. We'll be understanding that a lot in this class.
So can I think of it like barriers? Basically saying it won't pass these.
No, it's not that it's barriers. It's that they said there was so much spectrum. There's about 200 kilohertz of bandwidth allocated to each FM spectrum. And they said, and then there's a guard band that the FCC uses. They don't typically put two stations right next to each other. If you tune on the FM broadcast band, you'll notice everything goes in odd multiples of 100 kilohertz, 101.1, 101.3, 101.5, 101.7. But even with that being said, most of the stations that are put up in a locale or market, I guess they call it a market, Colorado Springs market is distinct from Denver's market because we have Monument Hill, which kind of acts as a barrier for the RF at that frequency from bending and coming down. It's too high a frequency for it to really skip very well like lower frequencies would. So those are two markets. So in our market, our stations, I think, mostly are separated by 2 channel slots. There's a space in between. We could investigate that. I won't do that today, though. But so they pushed out to the edge with that overlay. So that overlay spectrum is to say, we'll leave the analog inside. The analog receiver will not know the difference. The HD radio receiver can capture those 2 rectangular blobs that are out there and then decode them. Analog, demodulate, and then decode them.
Okay.
Does that make sense?
Yeah.
There's a waveform that I worked on one time at quite a few years back at RT Logic called Advanced GPS, and now it's going to do that because it's thinking my battery needs to be saved, so I'll get rid of this. And that used a similar type of modulation idea where you would put the overlay, the new Advanced GPS, was spectrally going to sit in 2 blocks like that either side, and then the legacy GPS waveform would be down the middle. I don't understand why this thing won't close on me. There we go. I'll make it happy and get power back. Wish I could do it both ways. I'd like to get the better microphone working. Okay, we've had a number of starts. Figured out something wrong with my dongle that splits from USB-C to a USB and a video and an Ethernet and an HDMI. Something with the driver is not making the USB part work right. Has everybody had that happen before, where a USB port just stops and it doesn't come back until you reboot the computer? Frustrating as it may be, it's just sort of a fact of life. Okay, so I think we're done with the website. What I want to do now, and he's changed resolution on me, so we were having problems with the colors. So John, when you eventually watch this video, you haven't been in the classroom to see things, but we don't have but 2 colors in the display right now. And we had problems with the microphone, and so I did some demoing and stuff. So now what I want to do is just kind of get into what the class is about, sort of on paper, and how it fits in with the curriculum. And then we'll go through the course syllabus. We'll also go through my policies, some of which I've already explained when we went through the website about the passwords for getting to solutions. And then I'll say a little bit more about the COM lab, even though I did that demo in hopes that somebody else would sign up for the lab. They were going to cancel the lab, and I feel really bad about that because of the fact that I worked so hard writing new labs. We got the donation of the new lab equipment. Our new dean is being really particular about how much enrollment we have in our classes. And honestly speaking, my classes are always rather small. So it is. I mean, I have 3 classes, though I don't have 2 big classes, so I still have a lot of work. I have maybe too much work, but I would like to see more people in the lab. So talk to me afterwards if you're thinking about it. I'm going to go to the lab on my way back. Hands-on is really nice for people in comm theory because a lot of junior engineers work in the lab when they're first on the job. They don't just sit at the computer and write code and know everything from the get-go. You have to get brought up to speed. And the lab and testing is a good place to get started. So I'll also talk about software tools and say a little bit about COM2. COM2 is offered every other fall. So this fall, it's due to be taught, and I'm going to be on sabbatical all of next year. So Dr. Semiari is going to be teaching that class in the fall if we get enough people. Now I have a feeling it's going to be a serious challenge because I've only had 6 or less in the class, usually less than 6, and his new hardline stance is it's got to be 6 people. So I don't know how it's going to happen, but this is my first pitch for it. The class can still go, but the professor has to agree to teach it as an independent study, which means you teach it as an overload, and you have to just accrue some credits towards a future offload. It's kind of not the greatest thing, and it'll be what it is. It used to be that way a long time ago, and then we stopped having to do that, and then I guess I got away with more than I should have. I should have been having a lot more independent study classes, but I didn't really speak up about it. It's like, okay, if this is good, if 4 people is good, if 3 is good, if 5 is good, would you say something? I mean, if they want me to do it, I'll do it. So, but now it's kind of gone around again, and it's becoming an issue. So I didn't get a chance to rotate this. I can rotate it, but do I want to rotate it? Okay. Dr. Plett actually prepared this for his classes, but I thought I would just show you that as an undergraduate, if you're taking the class, this just fits in as one of your technical electives. So, but it also is a breadth lecture class. So those of you that are taking it as an undergraduate are probably using it as one of your breadth lecture classes, right? You know what I'm talking about? those courses that you have to have. I'll just flip this up here for a second. This is my graphic that shows how it is. So comm theory is right in here, and it's one of the 12 credit hours of breadth lecture that you have to have for your BSEE. This is what I used at open house last week a lot, but I created this a long time ago. It's building a house. So if you haven't been building your house, you're not about ready to graduate yet, but you start at the bottom and then you gradually work your way up to the top. Another way of looking at it, which I think is better if you're a graduate student or just want to see what else is out there, would be this view on it. And that is within the area of communications and signal processing, which you saw over here is this vertical stack right in here, CommDSP. How does all that play together? So you've had signals and systems courses. You come from 3205, say last fall if you're a junior, or the previous year if you're a senior, and then you can come over and you can take Comm Systems 1 now, Modern DSP last fall. You can take them both. And then you can see in the blue, there's the link over to the Comm Lab. And I've got the blue up there because that's undergraduate curriculum, whereas Comm System 1 and Modern DSP, they're in the undergraduate curriculum, but you can take them for graduate credit. So they're dual listed. So some of you are graduate students and some are seniors. If you are taking the senior rule, I'm calling it the rule, that's not what we call it, but where I went to school it's called the senior rule, where you would start taking graduate courses before you actually graduated and then you could apply them to your master's degree. Then you would want to do that with this class perhaps, declare it.
Is it allowed to 2-in-1? So if you do it for your undergrad, but then can you also apply it for your grad?
Yeah. I don't know the rules on it though. When I was in school we didn't do it that way. You couldn't double count anything, but now with our program you can.
Maybe ask nicely.
Pardon me?
Maybe just try to ask nicely.
Well, no, you go in and talk to Eva about applying for that program, and then you get to do that. But I'm pretty sure you have to take it as the 500. I'm not positive. When I was in school, that's what you had to do. You had to actually take it as the 500. Is that the way it works?
Yes.
Yeah. Yeah. I'm just pointing that out so you can still do it if you want to. It's not, we haven't passed the census date yet. So they have some other classes that are in here. We have real-time DSP, which I'm teaching right now. That's my smallest class. That has 4 people in it. That one would have not gone this semester if it wasn't for Dr. Kelker fighting for me on it. And if you're interested in that class, that's very hardware, hands-on with the Cortex M4 processor and A to D and D to A converters. It's a lot of fun. It's programming in C primarily. And then Comm Systems 2 picks up in the fall. There's 2 classes at the end. Because I don't have my stylus, I can't scribble on this, but you see satellite communications, which right now it's in suspension because the faculty that taught it left, and then the new faculty this is first year, so he hasn't really gotten up to a full load. He's probably going to teach wireless networking, though, is what I've been trying to suggest that he teach. He kind of agreed to that when we were interviewing him last spring, and I'd like to see him do that. So the problem is because I'm on sabbatical next fall, he's going to be teaching Modern DSP and COM2 for me, so he probably won't teach anything else, because when you're a young new faculty member, you get to say, I'm given this privilege of not being fully loaded until I get bigger and stronger. So you're treated kind of like an infant for a while, because you're supposed to be developing research and just getting assimilated. So I don't remember being treated that way myself, because when I started the program, our department was small, and I just said, I'm going to do it because I want to do it. But we have more policies than we ever used to have. So I guess if I was in his shoes, I wouldn't volunteer for more work than I felt like I had to do. But those are out there. But then I'm offering right now down below here the phase lock loop, and it was frequency synthesis, now it's synchronization. And that class has got about 7 people in it right now, or 7 or 8. I guess it's 7.
Is that this semester?
Yep, it's on Wednesday morning. It's on tomorrow morning at 8 o'clock down in Columbine 136. It'll probably be the last time it'll ever get taught by me because I'll retire before I would ever be able to teach it again. And it's been very much a specialty class. So I've been accumulating students. I have 3 master students that I'm advising that are in the class, and they've been kind of waiting for it to get offered. So in this class, we do study phase lock loops. So you will be simulating a phase lock loop in Python. You'll also be having playing with a hardware phase lock loop in the lab itself. So they're out there, and I'm not going to get carried away on what they're good for, but you really need to be through this class before you would take that class. That's what the prerequisite is. So I'm not trying to talk you into it, but it's got enough people, so I would be untouchable even with the new system, as it turns out. I was kind of surprised at that. The syllabus, I'm just going to go to my drill down syllabus page since it's a little bit bigger. This is what I handed out to you. So this has the particulars of office hours, how to get a hold of me, my email. So I have time before class and after class. It's got the book on here, which I have paper copy. I have the ebook version. The ebook version is probably the best value. There's other things out there that the publisher was trying to get me engaged with. I just didn't pick up on all the stuff they were sending me. I'll just let you make your decision. The final exam will be open book, open notes, but I have 2 copies of the book, so I will have those here. So don't let that hinder you from deciding which way you want to go. Because I'm riding a bike now with a pack, and I can only carry so much stuff around. The ebook is definitely a lot lighter. Books are heavy, but I don't know. You have to decide for yourself how you want to do it. Aren't they about the same? It's a little bit cheaper for the ebook, I think, right? Is it half or 2/3?
Not how I found it.
Okay. I don't think the book is really all that expensive compared to some books that are out there. The principal author, Roger Zemer, was my dissertation advisor at Missouri S&T. He taught here. He's the one that brought me here. I mean, I had the opportunity when he became a department chairman. He goes to my church, so I was actually over at his house because I'm trying to teach him Python. He's got Parkinson's. He's kind of not in the greatest of shape health-wise, but he said he wanted to learn, so I set up his computer, and I see him every Sunday, so he's pestering me now like, I can't get this to work. And so it's kind of fun. I mean, all of you have, as you get older and older, you have family members and you just do stuff, and I'm kind of excited. He also helped me with the Signals and Systems for Dummies book, which I didn't bring down here. It's available. It just has a review of linear systems theory, and it's kind of was my inspiration for getting into Python and getting things to where the open source project that we're going to be using for this class is to this day. Its 3rd anniversary of being an official open source project will come over spring break this semester. So I'm glad I did that, and now it's growing bigger. We're actually going to partition it. It's already started to get partitioned on a different GitHub site, but that'll be happening kind of behind the scenes, and I'll kind of announce things. But it's now growing into, it's splitting up into a hardware. The hardware portions are going to be broken out, and just the straight software stuff is going to be the core Scikit DSP-Com. If that means anything to you right now, it's going to mean something to you as you move through the class, because I'm not advocating the use of MATLAB at this point. You can certainly use it. It's very powerful, but I think you'll find that Python is very nice to work with, and you can take it anywhere. You don't have a license restriction, and I'm a huge fan of that because places I consult at right now, they don't want to buy me a seat of MATLAB. They just don't do it anymore because it's just too expensive. So, and now I have hardware interfaces to do real-time DSP and the software-defined radio stuff that I can do in the Jupyter notebooks. So optional software, I only say optional because if you want to use what I have set, what is in the labs, you can. Python is on all the lab computers, but it's not necessarily totally set up. It gets put on. I give them the recipe, but you've got to configure things. I recommend mostly just putting it on your own personal laptop, whether it's Mac, Windows, or Linux. They're all supported. There's different nuances to all of that, and I'll take you on tours of that on GitHub because I did teach a workshop and have some recipes for getting some of the hardware stuff up. But the straight software only part of the Scikit DSP-Com and everything else that goes with Python, that's very easy to get set up. And it's easy to mess it up, though, if you're not really tuned into that. And the next page of the syllabus, or the backside, goes into that in a lot of detail. And I'm sure I'll be helping some people in my office that just made a wrong turn, and I'll help them fix their install. Now the grading is the official contract that we have. I call it the official contract because this is binding through the end of the semester unless I agree mutually with your consent to make a change to it. So it's up to you to hold me to it too, but I don't plan on making any changes. But if something seems obvious, like we get lots of snow days or something, I mean, I might feel like I need to change something. So the first item is quizzes and/or homework assignments for a total of 20%. At various times I've done just quizzes, I've done just homework, and with this class I could do just homework, but I think the quizzes are good because they sharpen your ability to work quickly on a problem so you're better prepared for taking an in-class exam. So the approach that I will take is there will be nominally weekly quizzes, except when there's an exam or a snow day or something like that. And then the way it will be is I'll give you a homework assignment, and then I will point out to you before the quiz, I'll say these few homework problems out of the total is kind of going to be the focus of the quiz problem. The quizzes are always two parts, so there's like a problem 1 and a problem 2, so you have two little problems to do something with. And then what I will do for the homework, because I'm going to be grading myself, I'm not going to let you turn in the whole thing for me to grade because it's going to be more than I have time to do. I will say turn in such and such problems, a handful of problems. So that way you get an opportunity to both turn in work and have it graded that way, because that's the way some of you excel better. I encourage you to do your own work, though. I mean, that's the thing about homework that a lot of us professors talk about at faculty meetings. People don't pay attention to the ethics and don't learn how to do something, and you gotta learn how to do stuff. So the quizzes are going to stand out there as the test of what you know that you can do independently. And I generally will let you have a crib sheet for the quizzes too. There's actually a crib sheet that's on the website that I'll either print it off and give it to you, or you can go grab it right now once I show you where it's at, just to have it so you'll know what is your security blanket to always have and to hold for the rest of the semester, whatever. So we're doing the overview and intro right now. We will focus for a while on signals and systems review, things that you've done in 3205 and started in 2610. But it seems like it needs review, especially the Fourier, and the Fourier is predominantly the only thing that we use in this class. We don't use much in the S domain except when we study phase-lock loops. So the Fourier, Dr. Zemer, my advisor, his analogy was it's like painting something. You have to give it multiple coats of paint for it to seep into the brain and really kind of be right there. and so you can be coherent with the Fourier. And Fourier series is also a part of this class too. And one of the things we're going to do as we move through chapter 2, we're going to pull Fourier series and Fourier transforms kind of together. We have a way that the book advocates the idea of the transform in the limit so that you can look at periodic signals as a Fourier transform, and there's a key theorem that allows that to happen. And of course the Fourier analysis that you're familiar with already. But then in this chapter we also introduce autocorrelation function and the power spectrum. And we'll also be dealing with the Hilbert transform, but that's in chapter 2, but I'll jump back and grab that when we talk about single sideband modulation in chapter 3. And the Hilbert transform has other applications in software-defined radio too, so I'll try to point those things out to you as we go through it. Sampling theory is in the chapter. It's just something we have to be aware of, and one of the sampling theory ideas that gets introduced in this class also is bandpass sampling, and that's a key aspect of software-defined radio, the idea of bandpass sampling, where you can undersample a signal and purposefully allow aliasing to occur, but it's controlled aliasing. So I'll wait to explain that to you when we get there, but it's pretty interesting the way that works out. And in your first simulation project, you'll also get exposed to multi-rate sampling, because that's a key part of software-defined radio too. You come in at one rate, then you do some processing, and then you downsample, and then you do some more processing, and you might downsample again. So multi-rate processing, which is part of digital signal processing, formally it gets introduced in the first project, just so you can lay your hands on it and kind of play around with that a little bit. Then we'll move into basic linear modulation, which is chapter 3, double sideband AM, digital pulse modulation. We'll be looking at a type of digital modulation called PCM, or pulse code modulation, and that is really just what you know right now of as an A to D converter. Just digitizing a set of samples with straight binary, signed binary encoding, or two's complement type arithmetic. And you'll get a chance to play with that in the second project, maybe even before then, because I have some things in one of the modules of the Scikit DSP-COM that allow you to do PCM encoding and decoding. So you can play with some digital ideas in there of digital modulation. Then in chapter 4 we do nonlinear modulation, which is frequency modulation, which we were looking at in the software-defined radio, phase modulation, which is used mostly in digital phase modulation, as in phase shift keying, and then a review of some other types of pulse modulation and multiplexing. That's not really a very sophisticated part of the class, and the phase lock loop gets introduced in chapter 4 as well. And then we'll have some digital transmission discussion. There's a chapter in the book, but I have a set of notes, and I generally skim through them because I let the final project be kind of your introduction to digital communications. COM2 is what spends a lot of time on digital communications, and when you take COM2 you also learn about random processes after having a review of probability and random variables, a quick review of that, but then random processes gets introduced in that chapter, or in that course. But some basic digital communications ideas. I did quadrature amplitude modulation in the project last spring, and then I had convolutional encoding and decoding in there. So then I had the PCM encoding and decoding, so you could take a speech vector, PCM encode it, send it as bits, protect the bits with a forward error correction scheme, and then so on and so forth, be able to kind of simulate, right in Python, a complete digital communications process. My hope is that that will now be able to take place right on the Pluto here of transmitting and receiving. But the thing that you have to realize, that I always have to remind myself with our simulation tools today, you can simulate pretty much everything on the computer, and whether you actually put the hardware in the link doesn't necessarily matter that much. It puts in some added realism, and it puts in some things that make your life hard, and that is the need for synchronization. That's why I have the class I'm teaching this semester with a synchronization, because digital comms requires synchronization. Analog does not. Our ear hears it, and we recognize it, and it works. But if you have a bit stream and you have asynchronous clocks between the transmitter and the receiver, how do you get those locked up and synced with one another? Have you ever thought about that? Clocks don't stand still. You have a crystal oscillator here and one over here. They're going to be drifting. They're going to be at least sliding past each other one way or the other. And if you don't synchronize properly on that waveform with some sort of a bit synchronizer, and then carrier frequencies also have a phase rotation. And if you're in motion, you have Doppler, so that's another impairment. So those are all things that make synchronization in digital comms so important. And GPS, you have to synchronize to that spreading code in order to get the time difference of arrival off of, signal 1, signal 2, signal 3, and then triangulate to get the position. It's all very cool stuff, but synchronization lies behind a lot of the digital comm stuff. Without it, you have nothing. You probably never thought that way. You thought, I turn on the radio and the signal's there, it's good. But digital communications, it's not good. You got to have synchronization because you have asynchronous clocks floating around. How could you make two clocks stay synchronous between 2 points? I mean, I haven't thought of a way to do that, right? You have to have a magic genie signal, and in the lab, you just take a cable from one generator and slave the second generator to it. But wireless, that's not what wireless means. So there's a lot of different things that have been created over the years to try to slave digital waveforms, from one means to the other. And if you have to do it wirelessly, then you have to have some synchronization technique, and that's where phase lock loops, things of that sort come in to try to synchronize locally from a reference that's coming at you. And you'll get exposed to that here. It's exciting, I think. So we're going to run out of time. We have 10 minutes left. So I'm going to just briefly look at this. I want you to kind of focus on this between now and Thursday and just see where we're at. I'm giving you some specific instructions about how to get Python up and running and what you have to do to install it. So I'm recommending Python 3.7 Plus, and that's what you'll get if you download the Anaconda package from conda.org. And if you go through that full installation, you'll have a lot of software on. I'm more along the lines these days of using Miniconda and creating a virtual environment, and that's what I have on here. But if you start with the full Conda, you can always rip it off and go with the Miniconda later if you want to. And then once you get a Python install on your system, scientific Python now is what I'm talking about. I'm not talking about the one that comes with Mac OS or Linux. I'm talking about one that's kind of tailored towards scientific computing, and that's what the Anaconda is all about. Then you'll want to put version control on your computer, Git, and that's the second. So you're going to learn about using Git and doing a cloning of a repository, which will be my repository with Scikit DSP.com on it. You might want to put some other tools on along the way. Some people like to use PyCharm Community Edition as an extra IDE. I like using Visual Studio Code from Microsoft. It's got lots of plugins to do different things with it. And I use that on Mac, Windows, and Linux, and it all works the same. All this software I'm talking about runs on all three operating systems. That's a very powerful capability. But then once you have Git on, then you're going to be cloning my repository, which, like I said, is moving, but it's still going to be present here for a while. In the new location, it's already in the new location, I guess. So I'm going to have to talk to my computer engineering graduate student who works at Cosmic AES, which is the best place. I think getting it from the new location. So I'll have to change this. But once you get it on your system, you'll be able to pull it again from another system. The idea of cloning a repository is, though, you're putting a set of software on there and then you're going to install it on your computer using an installation procedure that I'll walk through next time. And if I make changes or if you have new features, you'll just do something like I've written down here. Git pull origin master will pull from the origin, which is in the cloud, and it'll pull the master branch of the software, and that will come onto your system and it will update your modules, and it will already be installed, and you'll just have the newest version. So it's going to teach you something that's kind of a valuable aspect of modern day software development for engineers and computer scientists. We all use it. Right, I was working at Cosmic and I'm kind of done working there now. I had to push things to the Git repository in the company before I left, and they'll merge it in. How many of you have never used Git before? Okay. Are you up for it? I mean, I want you to say, I want to try something new. I want to get exposed to this, because it is, those of you that have used it, would you agree that it was a good thing?
It's good. I mean, I've looked at it. Most of the developers that I work with use it. I only see it and pull something out of it. So
Yeah.
I'm very amateur.
Well, I started that way too. When I was working 7 years ago at Cosmic, the chief engineer said you had to get Git, or Git, whatever. I mean, he said you had to get it. You had to use it. So, because you work in teams, and the computer scientists are big on that. Agile management is I'm on agile teams, team management strategies. There's some optional software in here which I'm not going to go into right now. So we've got 5 minutes left. I could jump back over here to the notes where I had left off. When I have homework papers due, I want them at the start of class. If you're on business travel or family emergencies or just things that you think are legitimate, you need to run it past me beforehand to say, I'm going to be out of town. Can I turn this in when I get back? What provisions are you going to make? Because I have solutions that I'm waiting to post, and I might extend you an honor code thing where I'll say, okay, I've got to post the solutions, you're on your honor. But I generally don't like to do that because I don't like putting unnecessary temptations out in front of anybody. I mean, you got to manage your temptations, right? If you know the solutions are out there and you can grab them, will you abide? I'm going to give you an honor code, though, when you work on projects later, too. So got to put some trust out there. And then I've already talked about how I'll have a password, and I haven't come up with a password. I'll announce that on Thursday. What's the password going to be for documents? Nothing is locked right now on the website. I started to talk about this earlier. What I want to do, though, because I'm giving you the assignment to go do something with Python, I want to show you how I launch it. So rather than carrying down on this, I'm going to go over, I'm going to go back over to here. And I'm just going to say, how would I launch Python? So the first thing I do for me is I've got it set up. If you're under Mac or Linux, you're just going to use the terminal or the shell. If it's under Windows, it's the PowerShell that is the same thing. So I'm in the PowerShell right now, which is something that maybe you don't spend much time in, but it's kind of where the action is to get things launched. So I'm going to launch it from here. And you can see there's a little thing that says base up there. So I've got Conda, mini Conda running on here. So I type my Conda tool, and you have to get this linked into PowerShell, and I talk about that in the back page there, what you have to do when you're putting it on for the first time. So I'm going to do Conda env for environment list and just see what environments I have on this system. And it turns out I've only got two. I've got the base, which really doesn't have any software installed inside of it, the minimal, and then I've got DSP-COM. So for me, if you put the full version of Anaconda on, everything will be in the base and you won't have to do this step. But for me, because my tools are all in the virtual environment, DSP-COM, I have to activate it first. and all installations work the same way. So I'm activating DSP-COM, and notice it's telling me in the far left edge there that I'm now in that environment. So that environment is available. If I was to type conda list, I would be able to see all the packages, Python packages that have been put in here. In particular, you'd see scikit DSP-COM is installed, and it's installed according to my GitHub site in the develop mode, so it's easy to add updates to it because it was installed in that fashion. So then when I actually would want to run a Jupyter Notebook session, I would type, because of what I've installed on here, I would just type Jupyter Lab, and it's now going to launch Jupyter Lab in the web browser, and it's launching right now. It's creating a local web server, and it's connecting to it. And I haven't been in this for a while, so I've got a bunch of notebooks that it's opening up from last semester's 5650, but I could navigate from here over to 5625, and then where I have my notebook stashed, and I could open that. I guess I might, without my mouse, maybe I can't do that. One of these though, chapter 2. This is on the course web page next to the chapter 2 note. So this is my intro notebook that's up there. So if you could get to the point where you could launch this up, this notebook is in a zip, and you put this on your system, and I would run some of the initialization cells in here. These are just configurations that I like to have. And then as a simple example, I'm importing all of NumPy and Matplotlib, which is the graphics, and NumPy is the vectorizing capability layer that gets added on to Python. Python doesn't have the smarts to do math unless you import libraries. So I've imported, I've used a magic up here actually, the %pylab, and then that brings in a couple of modules. It tells me that right up here, populating interactive namespace with NumPy and Matplotlib graphics. But then this cell right here, I'm creating an axis of times. I'm creating a cosine of 2 pi times that time, and then I'm plotting it, and I'm adding a grid to it. So it's typesetting a lot of math right now, so it's not paying attention to running this cell, I guess. There we go. So it's created a plot for me, and you can have cells that have math in them and text. You can define functions. So scroll down through here, and you'll see I wanted to define a piecewise function that matches the piecewise math over here. So I just put a function definition in here, and then I called into that function, and I created a piecewise function right there in the notebook. So what's cool about the notebook, and I'm over time now, is that everything is in the notebook. I close this notebook, I open it up. My brain doesn't have to remember what was I doing at the command line like in MATLAB, or Python has a command line. The notebook is archiving it, and this is good for turning in homeworks and doing a lot of work. I can give you template notebooks for projects to get you a head start. I can do lots of things in the notebook, so you can just grab a notebook and get started without having to start from a blank slate. Does that sound exciting? To me, it's very exciting. Chris has been in my classes, so he knows that I like to do this. I don't like to give things away. I just simply want you to have a starting point. And what happens when you're working 5 classes is you're task switching, right? I go through task switching. Does everybody know what task switching is? You're on this topic, you're so focused on it, you got to switch back to this other one, and it's like your brain is just racing down this path, and you got to pull back, and then you got to start driving on that path. It doesn't get easier when you get older. I'm not sure it's harder. It's just task switching is challenging as a student and as a professor when we teach different subjects. So the notebook helps you though, because you can write notes and you can get back into your mode again quicker. Okay, well, have a good rest of the day. Hopefully I'll have a good cycle home. and stop my video.